Hello, this is question 7 from the 2017 MAT. A simple computer can operate on lists of numbers in several ways. Given two lists A and B, it can make the join A plus B by placing list B after list A. For example, if A is that, B is that, yeah, you add them together, you get all of them. Given a list A, it can reverse the sequence RA, listing A in reverse order, okay? Given sequences A and B, express R A plus B as the join of two sequences. So R A plus B, so you're going to get all of A plus B, then you're going to reverse it, which means that we are getting, well, we'll have RB plus RA. Right, so that is RA plus B, RA plus B. What is RR of A? Well, you reverse it twice, you're just going to get back where you started. That is going to be equal to A. Right, that's a nice start. Given a sequence of length, sequence A of length n, k is between 0 and n inclusive, then the kth shuffle, sk of A moves the first k elements of A to the end in reverse order. Right, so S2, let's just get a handle on this. So we've started with 1, 2, 3, 4, 5, S2, so they take the first two, stick them at the end in reverse order. S3, take the first three, stick them at the end in reverse order. Right, given two sequences A and B, both of length k, express SK A plus B as the join of two sequences. Geez. Right, so two sequences A and B, both of length k, right? That's the important thing. So they're going to take all of A and leave B, and then stick A reversed at the end of B. Right, that makes things a lot easier. So SK A plus B is going to be B plus RA. What is SK A plus B? So now we do SK A plus B. So that will take all of B and stick it at the end in reverse order and leave RA at the front. So we've got RA plus RB. Right, that was so far so good. Now let A equal that. Write down S5 of A as a join of three sequences that are either in order or reverse order. Show that the sequence A is back, three sequences. Show that the sequence A is back to its original order after 4 shuffles. Right, three sequences. Right, well, let's just write out what we're getting. So let's go through it all. So we're starting 1, 2, 3, 4, 5. Oh, up to 8, 6, 7, 8. So we do an S5 on it. So that's going to go 6, 7, 8, 5, 4, 3, 2, 1. And then we do another S5 on it. So that'll be 3, 2, 1, 4, 5, 8, 7, 6. Right, so what? Join of three sequences that are even in order or reverse order. Okay, so we've got a 1, 2, 3 in reverse order, a 4, 5, and a 8, 7, 6 in reverse order. So write down that as a join of three sequences that are either in order or reverse order. So we've got, well, R 1, 2, 3 plus 4, 5 plus R 6, 7, 8. Right. Show that the sequence A is back in its original order after 4 shuffles. So that's 1, that's 2. So we do it 2 more times and see it gets back where it started. So 3, we're going to have 8, 7, 6, 5, 4, 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8, which is what we want. Right, okay, I'm wondering where this three sequences thing's coming in, whether I've actually written that the right way or not. I don't know, whether they actually want it written out as like B, C, and D or something like that. I don't know. But I think that's clear enough. Now let A be a sequence of length n with k greater than or equal to n over 2. prove after SK is performed 4 times that the sequence returns to its original order. Right, this is what we've just done, isn't it? So we have just done this. We have just shown, so this was for length 8. So n is 8 and we had k is 5. So k is greater than or equal to n over 2. And they've got us to split it into these bits. So, and we've split it into a 3, a 2 and a 3. So, and that's going to be, how have we split these then? So these first two are adding up to k. So yeah, let's get a, yeah, how are we splitting this up? So we've got these two add up to 5, these two add up to 5, and we got the bit in the middle. Yeah, so we're splitting it then into, what was that, n minus k. So we've got n minus k for the first bit and the last bit. And then in the bit in the middle is going to be 2n. No, it's going to be n minus 2 lots of that. That's going to be n minus 2n plus 2k. So 2k minus n is what we got in the middle. Right, so that's how we want to split our strings. So we're then, well, they're not really strings, but sequences. So we're now doing that. Prove if that, so let's say then we start off with our first sequence is going to be, yeah, this length of n minus k. So we've got some sequence of n minus k. Then we've got some sequence of 2k minus n, and then we've got some other sequence of n minus k. So we come in then and we do an sk on this. Right, so let's call this A, this B. Oh no, we've already got A. Let's go X, Y, Z. Just easier in it for 3 things. So if A is equal to X plus Y plus Z, I'm going to be able to fit all this on here. I'm going to need a new screen. Well, yeah, let's go new screen. So n minus k, 2k minus n. That's what we got. So n minus k, and then 2k minus n, and then n minus k. So that's x, that's y, that's z. So we're saying that A is x plus y plus z. Then we're doing sk of A. So sk of A is going to go to, it's going to take x and y. That's the whole point of us splitting it that way, because we add up that and we just get k. So we get z plus r x plus y, which is, yeah, we did r x plus y earlier on, didn't we? I believe. R x plus y is r y plus rx. So that is going to be z plus ry plus rx. That's what we did in some earlier part 1. Right, okay. So now we're doing sk of z plus ry plus rx. And that is going to be equal to rx plus y plus rz. And then we do sk of rx plus y plus rz, which is rz plus ry plus x. Sk of rz plus ry plus x is x plus y plus z. Yeah, so we're back where we started. So back to start after 4 sk. Right, that was good. Satisfying to get to the end of that, but it nicely built up. If they hadn't, it would have been a struggle if they hadn't have said join of 3 sequences in part 3. If we didn't have that, then we would have had to stab around in the dark a little bit, I think, in part 4, probably doing it wrong a couple of times and then realizing that it's 3 sequences. But they put that in part 3 to help us out. Right, last part then. Give an example to show that when k is less than n over 2, the sequence need not be in its original order after sk is performed 4 times. For your example, how many times must sk be performed to first return to the sequence to its original order? Right, do we just go for the easiest one? Do we just say a is equal to 1, 2, 3? And that k is 1, n is 3, and just do it off of this? Is that going to be a con? I don't know. Let's see. Maybe it doesn't work. Maybe that's what it is. So let's do. So we want to do S1 of A will be 2, 3, 1. S2. Well, no. S1 of 2, 3, 1 is going to be equal to 3, 1, 2. S1 of 3, 1, 2 is equal to 1, 2, 3. There we go. So we're back after 3. And we need to show that it doesn't then work for 4. Well, clearly not, because it's going to go to 2, 3, 1. So there we go. So that is after 3 times, and it's not back after 4 times. Maybe if we had a different way of doing it. What if we had 1, 2, 3, 4, 5, and we went with 2? 3, 4, 5, 2, 1, 5, 2, 1, 4, 3, 4, 3, 1, 2, 5, then 2, 5, 1, 3, 4. So that's not back where we want to be. Is that right? I might have done that wrong, haven't I? Have I moved 3 to the back that time? Oh, I have. I've been doing 3, not 2. Actually, that one I did 2. And then that one I did 2. But this one I didn't. That should be 1, 4, 3, 2, 5. And then that one should be 3, 2, 5, 4, 1. Okay, yeah. I'm still dealing with 3s on the from the previous part of the question. So that's not back where it started anyway. So that's 1, 2, 3, 4. So it hasn't worked. How many times would you have to do it? 5, 4, 1, 2, 3. 1, 2, 3, 4, 5. So you'd have to do it 6 times. So you could have either of those, would work out fine. Right, so that last part of the question was pretty straightforward. It looks like you could probably pick most things out of that. Well, I could have done it with 4 actually, yeah. 4 and 1. Actually, 4 and 1 would have come out with what we wanted, because you're just looping each one back to the back each time, and then it would come out with looping back after 4 attempts. So that doesn't really work as a good example, but either of these do. Yeah, fairly interesting question, I suppose. I mean, part 1 was pretty easy. Part 2, part 3, actually all of the first few parts, it was spotting that thing of these 3 sequences that they led us into in part 3 and how that helped in part 4. But a nice way to finish off the paper, I think, for this one. I think question 7 was a bit easier than 5 and 6. 5 and 6 were trickier, at least in my view. You know, people have different views on how these questions go, but I think this was a bit better than those, for me at least.